Let's review how to find domains of definition. Domain of definition of a function. So, given a function, remember that the domain is the set of all possible real values for a real function, such that you can compute these number f of x. When you substitute the quantity, your quantity x inside the formula, you get a finite real number. So this is uh, what uh, um, this is the definition of the domain. So we have family of functions that um, usual one, for example, if your function is polynomial, so then we know it's the domain is everywhere is R, because there is no, for any x you can compute powers and multiply by constant and add quantity real numbers. Okay, if you have fx a rational fraction that is polynomial over polynomial, here the only values you need to remove are yes, to eliminate are the values where, so we eliminate the values where q of x, the denominator is 0. We need to remove this. In case you have a formula given by where square root is involved and an expression, for example, p of x, uh, so any expression, so the domain then also, so then the domain would be the set of all x's such that your expression inside the square root should be positive or equal 0. So mainly these are the tools we will use in when we practice finding, looking for domains. Okay. Okay. So let's then start with first function. So the question is to find the domain of definition. So here is my first function. Fx is x2 minus 3x plus 2. So I have a polynomial defined everywhere. So here is the domain. So the answer here is quick and easy. What about now my function is 1 over these polynomial. Name polynomial. Okay, so x2 minus 3x plus 2. So here I will say that my domain, I will look for all the possible real numbers, okay, such that I have x2 minus 3x plus 2 different from 0. That means I need to just to identify. So let's solve, identify the x's that gives me 0 for this expression. So solve x2 minus 3x plus 2 equals 0. So let's use delta. Delta is minus 3b squared. So let's remind you about the delta, just it's good to remember. Okay, so it's b squared minus 4ac, if you remember. So minus 3 squared minus 4 times 1 times 2, which is 1. So it's positive, so I have two roots. X1 will be minus b plus square root of delta over 2 times a. So remember, this is for polynomial. When you solve the polynomial ax2 plus bx plus c equals 0. Okay, right here. So yes, then minus, so it will be 3 plus square root of delta is 1 over 2 times 1, which is 2. The second root will be minus b minus square root of delta over 2a equal 3 minus 1 over 2, which is 1. So finally, I need to eliminate these two values, 2 and 1. So I will say my domain. So let's suppose I have a line here. So I will say I have to eliminate 1 and 2 and consider all the remaining values. Okay, so you have two ways to express this. Either you use df equal r minus those two values, 1 and 2, or also notation, interval notation, on minus infinity to 1, union 1 to 2, and union 2 to plus infinity. Okay, Now, let's now use the same expression, but this time, what about 3 a square root? So this is the same expression. Okay, square root of, again, x2 minus 3x plus 2. So, yes, um, that me. So here I have square root, so I need to look for all possible values so that the expression inside must be positive or equal 0. So because we have, remember, when you have here the decomposition here, when you have found your roots in, when you are able to find the root with delta positive, you have this factorization x minus x1 times x minus x2. Okay, in case you have delta positive. So you have this factorization. Sorry, here I mixed the notation. I want to yes, write it in general situation. So this is what I wanted to say. So this is what we will, yes, because we have a second order inequality. So we learned how, we know how to do it using, for example, a table. We factor the idea of using inequalities is through the table. Factor the expression, use table of signs and deduce the set. Okay, so here the same, we have simple situation. Let's do it then. Okay, so we have, let's see how many we have. We have, so one factor, let's say, yes, 6 minus 1, the second factor, and then the product. Okay, here is x. So my factor, we said, I can factor my expression here, x2 minus, so or let's write it here. Okay, my expression, I can write it here as x2 minus 3x plus 2 is equal x minus 1 times x minus 2. Okay, so I need to explore the sign of x minus 1, each factor, x minus 2. So if you remember, we do it by solving a simple inequality. When do I have x minus 1 positive? This will happen if you have x greater than 1. Okay, solving linear equation. So it's easy. So let's do it. So we have the value 1 that appears, and for the second term that you have 2. There it is. So we have 1 and 2. Yes, so this expression will be positive if my x is greater than 1. Positive equals 0 here and negative here. Similarly, for x minus 2 will be positive here, equals 0 here, negative. So that the product will give me plus, negative, and plus. Okay, and my domain now, I can read it. I want the x's that gives me the product or the expression positive or equal 0, 0, so here it's 0. If one of the factors is 0, then the product is 0. Okay, so I can read my x's are taking values from minus infinity to 1. So minus infinity to 1. So there is, yes, the notation, and there is other notation. Okay, so you have either some books, yes, you can use the open interval, minus infinity, 1, 1, okay, union, so 1, I can include it because I need or equal 0, then 2 and plus infinity. This is my domain. Okay. Now, what if we were, so what if we were have, what we had, or what if we had now the other expression? what if we had to solve this situation? Okay, so let's write it here. For situation 4, if I had my function like that, okay, 1 over x2 minus 3x plus 2 plus this expression. Okay, I have, yes, x2 minus 3x plus 2. Then my domain, for my domain, I will say, I will look for the domain will be the set of all real numbers, possible real numbers, so that I need to eliminate 0, defined the denominator different from 0, and the expression positive or equal 0. Okay, so I know that my expression is positive here. I know it's different from 0, when everywhere unless we, okay, so that means I need to take the common points between the two sets. It's like, because you have an intersection here, okay, so you want either you take the intersection, but you can visualize it using a line also. Okay, so we have 1 and 2. So for the first expression is defined everywhere, we need just to eliminate these 2. Okay, but the second, it is defined at 1, 2, but remains positive outside. Okay, so let's say it's with the 2. Okay, for the other one, let's use maybe a color. The other, it's eliminating 0, 1 and 2. We can maybe, yeah, use a line above this one. Okay, so for the other one, so maybe, yes, we said we take everything. We avoid just 1 and 2. Yes, so then I can, I think, remove this part. Uh, so what are my common points? This is my what I want to do here. So I said 1 and 2 are considered, 1 and 2. So this is the domain for the first one, okay, for the square root. This is to assure that x2 minus 3x plus 2 is positive equal 0. The other line is to shows where x2 minus 3x plus 2 only is different from 0. Okay, but we want both to be satisfied. If I want both simultaneously, when I choose an x, I should be satisfying this condition and this condition. So I cannot take it here. If I take it here, I will satisfy this one, but that I'm not satisfying the second one. So yeah, if I look to the common points, I will have minus infinity up to 1, 1 excluded because I want both of them. So I need to exclude. Here I will need to exclude 2 and take the other positive values above 2. So this is how we do. So the difficulty in finding domain of definition is not just characterizing the domain, but the difficulty comes because it involves inequations, equations, the second degree, first degree. So that's why, so a good practice, knowing solving inequations and equations will be very helpful.